Hi, my name is Viktoria, a trader and a long-time Hummingbot user. Today I'll share a tool I developed during this Hummingbot bot camp that helps to find the best trading pairs for cross-exchange market making strategy. And the approach I used here can be adapted for other strategies as well, so think of it as a concept that you can modify to solve similar challenges. So, cross-exchange market making. It's a trading strategy where you place limit orders on one exchange while hedging on another exchange to profit from price difference. And the key aspect here that you need to place limit orders, which means your capital gets locked while waiting for trades to happen. Here is a quick picture of the strategy with limit orders on one exchange and market orders on the second. And you need to have here both capital on both exchanges. And this locked capital creates a challenge. Which trading pairs should you focus on? Historical data can help, but it can't reliably predict the limit orders fields, so I prefer real-time testing in this kind of strategies. It's more reliable, but testing thousands of pairs across exchanges requires significant resources and capital. And that's why I designed Cross-Exchange Market Making Explorer. It helps to mitigate at least some problems in the search, making this testing easier to handle. So how does this tool actually work? The main idea is pretty clever. Instead of doing both sides of cross-exchange trades, we only execute one side for real and simulate the other. Think of it like this. We place actual limit orders on maker exchange, and when these orders get filled, we just check what the price was on the other exchange at that moment. So no actual trading on that second exchange's price check-in. This way we can see what profits we could have made, but with much less complexity and risk. And what makes this really practical is that you don't need base assets to start testing, just quote currency like USDT. The system handles buying and selling in a ping-pong manner, buy first, then sell, so your capital is used efficiently. This means like minimal exposure to multiple assets that typically you need to have in cross-exchange market making strategy. So the system works through two main components, the executor and the controller. Executor handles individual trading pair logic, and the controller manages multiple executors and makes decisions about which executor to open. So executor is just based on the cross-exchange market making strategy. It also handles the make order routine of placing and canceling orders. But when the make order is filled, instead of placing the taker order, it just captures the taker price and stops the executor. And the controller manages all trading pairs at once. It creates only one executor per trading pair. And for that, it checks available balances, and if there is a base asset, it opens the sell executor, or if there is no base asset, it places buy executor. And next, I only need to analyze the closed executors in this controller and their theoretical P&Ls. The controller already calculates these statistics for me, but in case I need a more comprehensive report, all the data is stored in the database. As I mentioned, this design is capital efficient. You only need cold currency like USDT to start. And here are the configuration parameters. Aside from pairs, exchanges, order size, and profitability, I also added an additional paper trade amount that is used to calculate the taker price and P&Ls. Also here are configuration for fee rates, as I prefer to set them precisely. I have also included a liquidate base asset feature that allows selling all residuals base assets after testing. Let me show you a real example now. I set up HTX as a maker and Binance as a taker exchange. I found that one bot can handle 20 pairs simultaneously without hitting rate limits. So let's first look at what will happen if we fresh start the bot. Here I have only USDT on the account. As I said, only cold currency is needed first. And the bot has been started after some time. We see here executors and statistics that is empty. And all orders here are buy orders. Now let's look at the bots that are already running for some time. I have here 4 bots and 4 sub-accounts. Each has 20 pairs, so 80 pairs total. And the task has been running for a week or so. Some of the executors, let's see, like one of the bots, some of the executors were terminated with negative theoretical P&L, some with positive, but the most interesting here part is the statistics table that shows the overall result. It shows the number of executed fields, the average P&L, and the projected API for each trading pair. However, these P&Ls need adjustment. They show P&L for the order amount, not the inventory. To get real API, we need to account for the taker part and also hedging cost. And with collateral and interest rates for loans, the real API is about 3 times less than shown here. And to test all pairs between those exchanges, I have here only 80. I can either set up more servers with extra capital or run tests sequentially, taking longer but requiring less capital. And you see that this process still requires time and resources, but at the same time it provides more or less reliable real market data. After initial testing like this, I can focus on the most promising pairs and test different profitability levels. It is easy to do so here with this Hummingbot framework. In conclusion, I would like to thank the Hummingbot team, especially Fede and Mike. Learning these new features has been fascinating, and this new framework completely transformed my approach and strategy development.